Okay, what we're going to do here, we're going to finish up Test 1 review, question number 20, and what we're going to look at here is the graph of a quadratic function, which if you'll recall, when you graph a second degree function, you're going to get a parabola. It's either going to open up or down, and in this case, because the leading coefficient is a negative, the graph will be opening down. So the parabola is going to have a high point, which is the vertex. And let's look at a graph of this function before we can go ahead and answer some of the questions. So hang on here. Let me kind of readjust my studio a little bit for you. And let me turn on my graphing calculator. Let me go ahead and try to get a decent picture of the graphing calculator for you. Alright, let's see if we can. There we go. Alright. So we're graphing. I always like to start in a standard window by hitting Zoom 6. Make sure we have the standard window. Now, I already have the graph in there, but basically the way I entered it. Okay, let's get a little closer if we can. I'm going to try to focus in on it. Y is equal to the opposite of x caret 2, which is to the second power, plus 4x minus 1. And remember, at the very bottom of your calculator, okay, let me try to focus for you as best I can. That key right there is what I started with. That's the opposite of key. This key that I'm touching now is the subtraction key, and that only comes in between terms. So you need to pay attention to the difference. But basically, when I push graph, you'll see the graph of my parabola. All right? Now, one of the things that I like to teach my students is that if you push the trace button, that will take you directly to the y-intercept. And in this case, I'm having a hard time getting a picture, but you can see the y-intercept is the ordered pair 0, negative 1. And after you hit trace, if you hit the right arrow key, you're going up to the very top of the parabola. And the very top of the parabola, if you estimate it, I know it's hard to see on my screen, but if you get to the very top of the parabola, you're actually at the ordered pair 2, 3. One of the quicker ways to see that, if you hit second function table, and again you scroll, I'm trying to get this in focus for you with the camera. It's a little hard to do when you're self-filming here, but to get an idea, you can see the ordered pair 2, 3 is in that list. And that happens to be the very top of this parabola. Now, later on in this course, we're going to learn much better ways to find the vertex of a parabola. But roughly, if I were to sketch this parabola, this being the x-axis and this being the y, the y-intercept is 0, negative 1. The vertex is up here at 2, 3. And the graph opens down. And then we have symmetry on this side. So the high point of this parabola is the ordered pair 2, 3. Now, when I ask you to find the domain of this function, basically the domain of any parabola opening a parabola that's a function is going to always be the set of all real numbers. Because think about what happens here. As these branches not only are going down, they're getting wider and wider and wider. So your scan from left to right, which is what you do for domain, is going to go across the entire x-axis. Range, I like to teach my students, since range is the y value, we're going to measure from bottom to top. We're coming from the lowest, negative infinity, up to and stopping and including the y value of 3. So my range will be written negative infinity, comma 3, inclusion because the number 3 is part of the graph. The vertex of the parabola is another name for turning point. In this case, that's the highest point on the graph. So the vertex is the ordered pair 2, 3. The maximum value of a parabola. Now, the only type of parabolas that have maximums are parabolas that open down. And the maximum value is the y coordinate of the vertex. Maximum refers to the largest output the function ever has. And if you look at this parabola, the largest y value is the number 3. Every other y value is less than it. So the maximum value of this parabola is equal to 3. Okay.